Hi guys, so today let's quickly go over some fundamental trig identities and then we will do some examples, right? So first we will go over reciprocal identities. So we know that we have sine theta, cosine theta and tan theta, right? And these three functions also have their reciprocals. So we have cosec theta, which is 1 over sine theta. Then we have sec theta, which is 1 over cosine theta. And the last one is cot theta, which is 1 over tan theta. All right, so we have these three new reciprocal functions or reciprocal identities that we will be using. So the next one is ratio identities, and ratio identities are, the first one is tan theta, which is equals to sine theta over cos theta, and the next one is cot theta because that becomes cos theta over sine theta. All right, now the third one is Pythagorean identity, and that is sine square theta plus cos square theta is equals to 1, right? The next one is tan square theta plus 1 is equals to sec square theta. And the third one is 1 plus cot square theta is equals to cosec square theta. All right, and I have explained this and derived these in a different video, which I will link in the description below, right? So you can have a look at that if you want to see how that was derived. All right, now the fourth one, the last fundamental that we are learning today, that we will be using today, is odd and even identities. All right, so odd and even identities, again, I have done a separate video on that, so you can go back and look at those. I'll put that in the description. So the first one is sine, because sine minus theta will be equals to minus sine theta, and that makes it an odd identity. Cos of minus theta gives us cos theta, so that is an even identity. All right, with tan, so if we do tan of minus theta, that gives us minus tan theta, so that means it is odd identity. And cot of minus theta also gives us minus cot theta, so both of these are odd identities. All right, now the last one is, so sec of minus theta is equals to sec theta, so that is a odd, so that is an even identity. And cosec of minus theta is equals to minus cosec theta, and that is an odd identity. All right, so make sure you know those identities as well, because that we will be using those in the examples as well. All right, now moving forward, let's do our first example. So our first example is sine x times cot x times sec x is equals to 1. All right, so now we will convert these ones. So convert left hand side in sine and cos terms. So sine not theta, we are using x, so sine x and cos x terms. All right, try and convert them. So we will have left hand side is equals to sine x times cot is cos x over sine x, 1 over cos x. All right, so now sine x divided by sine x cancel, cos x divided by cos x cancel is equals to 1, and that is equals to right hand side. Right, so that is our first example. So here is our question number 2. All right, so again we have left hand side and right hand side, so we'll start with left hand side. All right, so we have 1 minus 2 sine square x. Okay, now we have just done the Pythagorean identity. Right, and that was sine square x plus cos square x is equals to 1. Right, so here we'll substitute the value of sine square x. So sine square x is equals to 1 minus cos square x. Okay, so 1 minus 2 bracket 1 minus cos squared x. Now let's solve that. So 1 minus 2 minus minus plus, so 2 minus minus plus 2 cos square x, cos square x. Now 1 minus 2 is minus 1 plus 2 cos square x, and we can write it in a better form, which will give us 2, the positive number in the front, minus 1, and that is what we need on the right hand side. So that is equals to right hand side. All right, so that is our question number 2, example 2. Now example number 3 here. So we have cos x square x minus cos square x times cos x square x is equals to 1. So let's take cos x square x common. So we'll be left with 1 minus cos square x, right? So we are doing left hand side. Now again, cos x square x, we know that 1 minus cos square x from the Pythagorean identity. So 1 minus cos square x will be equals to sine square x, right? And we are going to substitute that here. So that is going to be sine square x. Now cosec is 1 over sine square x times we have sine square x. So sine square x can cancel. So we are left with 1, and that is our right hand side, right? Now in question number 4, we have sine x over 1 plus cos x is equals to 1 minus cos x over sine x, right? Again, we'll start with left hand side. So let's write that down first. Now in this case, when we do not have anything to simplify it into, we times and divide by the conjugate. So that will be, so we times and divide with the conjugate, 1 minus cos x over 1 minus cos x, right? So that will give us sine x times 1 minus cos x over, this can be, now this can be a plus b and a minus b, right? And we know that a plus b, a minus b is equals to a square minus b square, right? So we will use that algebraic identity. So that will give us 1 square minus cos square x. 1 square is 1, so that gives us sine x 1 minus cos x over 1 minus cos square x. Again, as in the previous question, we use the identity. We know that sine square x is equals to 1 minus cos square x. So this will become sine x over sine square x and 1 minus cos theta. So sine x will cancel one of the sine x. So we are left with 1 minus cos x over sine x. And that is what we need on the right hand side. All right, cool. We'll do one more example, and that's all for today. In the left hand side, we have sine x plus tan x over 1 plus cos x, right? And on the right hand side, we have tan x. So we have to convert that into tan x. So first step that I'm going to do is I'm going to convert tan into sine and cos, because that's an easier thing to do. So let's do that. So we have sine x plus sine x over cos x, 1 plus cos x. All right, so now we can times with cos x. So just solve that top fraction, solve the numerator. So we will have sine x times cos x plus sine x whole over cos x, and then whole 1 plus cos x. All right, now we can take sine common, sine x common. So sine x common, we are left with cos x plus 1 over cos x over 1 plus cos x. All right, so now let's divide it into two fractions. All right, write it in the division form just to simplify it easier. So we will have sine x over cos x, and on the numerator we have cos x plus 1 divide by 1 plus cos x. All right, so that will become sine x over cos x can become tan x, and then we have cos x plus 1, and that division to convert it into multiply will be 1 over 1 plus cos x. So cos x plus 1 and 1 plus cos x is the same thing, so that can cancel and we are left with tan x, and that is the right hand side. Right, this is a bit tricky, so make sure you practice this question yourself as well once. Great, have a good day.